Tarwadi. I am from M.Tech Mechatronics, SMBS IIT Chennai. Today my seminar topic is automation using SCADA and PLC. We will see actually automation in so many plants, like mainly in process plants regarding PLC and SCADA. In process instrumentation or process automation, then we will see manufacturing, like so much things nowadays are automatic are there. So I will tell you in the process automation, specifically SCADA and PLC combinedly used to control manufacturing line or process in oil and gas plant. We also see there are lots of processes are there. When they pumps out the oil or these things, they will separate lots of things from that main oil which is coming outside. So using automation, using PLC and SCADA, they will also sort out the things. So basically, I am going to this is my seminar overview. We will see there are several different factors or points are there. First is introduction about what is automation, how PLC SCADA works combinedly. Then we will see what is deeply what is the SCADA. SCADA is supervisory control and data acquisition. Then we will see the PLC like programmable logic controller. Then in the last we will see application of SCADA and PLC. In the last we will see one application regarding PLC. Next is introduction. So first is that industrial SCADA and PLC system is used for the development of the controls of machinery. Here we will see this is the control room. In the process industry or in the manufacturing line, we will see one control room is there. All the controllers like PLCs are there with SCADA system. Like here we will see this is the front panel for SCADA. They shows different kind of things. Then here we see the south side of India they show. So using SCADA they will checking that, and using controllers they will control the things. So first of all, automation. Automation is what state of being automatically controlled. Means there is no human involved in this process. The second is tools of automation. Basically there are four tools used for automation. First of all, I say one thing. In the history, they will use relay logics. We will see in the relay there is normally open, normally closed position. When the relay or solenoid also, when they are energized, any one point is transfer to normally closed to normally open. So the same thing, same technique used in the past, now it is implemented in the PLC, in the controller, to do the same logic controllers. Second thing is supervisory control and data acquisition, which I explain you later. Then third one is HMI. HMI is human machine interface, like touch screen. Everyone uses mobile phone. You will see, we will put any key, press it turns and it's work. Same thing there is HMI panel. In HMI panel, all the diagrams on off keys are there. The manufacturer will place only that key, and on the base of that, the system respond to that keys. So HMI is nothing but human to machine interface thing. Next is variable frequency drive. Variable frequency drive is various drives are there. We will see there are lots of motors are there, like DC motor, induction motor. To control the speed of induction motor, DC motor, these drives are used. The name implies that variable frequency drive. If frequency changes according to that, we will change the speed of the motor. Then next will be. So first one thing is SCADA. I will tell you SCADA is very much supervisory control and data acquisition. Now SCADA is nothing but a remote sensing device. It is nothing but software. You will see here all the things are designed. Where water will come, stroke will come, mix up here, then transfer the things. So you will see there are two types of walls also in our theory, pneumatics and hydraulics. We will know one of the wall is centrifugal wall, positive displacement wall, then non-positive displacement wall. So this is nothing but a non-positive displacement wall. When force comes, it sends forward the tank. So we will see here also we will see reactor, batch control, historical trends, alarms, maintenance, conveyor. Now remote sensing. First of all, what I am saying, SCADA is nothing but a remote sensing device. Remote sensing is what? Now I am standing on the ground floor and my process is going on to 10th floor or 8th floor, and I want to control that process, or if my water tank is filled on 8th floor and I want to see from here ground floor how much it rising the level of the water. If there any error is coming there, I want to see that error is here. Like in in this process we will see, so like this wall is failed or this tank is having some problem. So in SCADA we will easily see this thing. Even you will see in percentage concentration these things are how much level is rising, we will see in this. Same thing, there are some things are there like a reactor for this historical test. Historical test is whatever in the already happened in the process. Like I start the plant, all the history of my plant till now it will be recorded in the SCADA software, and at any time I will change that history trend. If there is how many at the end of the day I will check how many faults are there in my SCADA system or how many problems occurred in the system. Then alarms is what, when any problem is there in the measurement check line, it rises and I will easily detect the problem. Next is the maintenance conveyor. To start the conveyor I will press this button. Maintenance whatever things I have done on my system means this is only one of the example of SCADA. Whatever that I am taking this reference, whatever he will do in this SCADA, he will only show the blocks. He didn't explain in the code. Then next will be as I am saying that this is remote accessing software. Then this is graphical representation of production process. In last you will see this is a graphical. This whole is the graphical representation. Means you see in the lab that is also a graphical user program. This is remote accessing means this is one of my HMI panel. I will press this all things and control the thing on whatever happening in my plant or in my factory environment. Next, one thing is there, it's SCADA is tag, which is similar to symbol in PLC programming terminology, which are explaining later when I will be talking about PLC. Tag means what? Whatever I want to assign some number or any address to that thing. If I given the temperature controller or any sensor to here, so I want to give any addressing for that. That addressing use SCADA to control or manipulate the thing, and same addressing fed up to the PLC to directly PLC will control the things. Here we will manually control the things. Even you will see in the SCADA, like last same we are going to Bangalore for ABB. In ABB there is one line like electric generators are there. So to maintain the level, like if it is 470 kV voltage will transport from that level wire, so they are using SCADA only for remote assembly like that. If they maintain the strength of that 470, it is they will giving some small range like 450 and 480. So my voltage should be in this range. It not be beyond that, not be below that. So they are using this SCADA for that. The thing is how I will take communication of SCADA with other devices, how it will be possible. So they use IPv4 and IPv6 protocols. Next one is the types of tags. Whatever I told you in tags, there are some types. One is digital, analog, string. Digital means what? Stores on or off information. Digital means we know that 0 and 1, only two things, 0, off, 1, on. Next is analog. Analog stores numerical values. Whatever I am giving the addressing, what I told earlier, they give the addressing. That addressing should be the numeric value or on-off information. Third one is the string. String is what? Any word I will give the specific word will give, like a tag. If there is one tag, I will put this a tag. If there is a wall, I will put this wall, like centrifugal wall or any other wall. If there is sensor, I will put level sensor or limit switches. Next is the data structure. Yeah. There are three types of data structure. One is device, memory and system tag. Device you will know, they simply put whatever done in the SCADA, whatever there are data structure tag. For device it is different tags. For memory, as I told you, this is a software. So in memory, separate tags are there. And system tag. What is the exact process done in that system is the system. See here, basically you see these are three PLCs. They show network LAN will be there, programming for any location. Now, like I told you, SCADA, I am sitting here and doing programming. My plant is anywhere else. I will control that. So same thing we will do in the laptop. I am sitting here. It is connected to PLCs via Ethernet. You will know Ethernet. It is a device used to interface the thing. There are lots of types of Ethernet like 10 based, 0, 2 based. Then same thing, it is the earphone. Nowadays it is wireless things also there, like OPC. You will see OPC means what? OPC means what? Object embedded and linking cross process control, means OLE for process control. It is specifically designed for all process controllers like PLC. They will give interface with directly the software mode. Same thing, it is advantages that like Ethernet having all hardware, Ethernet having disadvantage that it is hardware and is then costlier also. But OPC is nothing but only a software interface. So due to this, the cost of the system also gets reduced. Same we will see these are the database where when it is communicating with PLC with my plant, also it is connected with LAN. LAN is like Internet is another type of LAN. Plus it is a database. Whatever I am doing in that my SCADA software, it is all stored in my database. Three things we will do. If LAN in local area, I want to go within my campus. Within my campus, the plant is there. I am in the control room and we will LAN. But I am here and my factory is somewhat long, so I will use WAN internet. The same thing will happen. Next we will see SCADA system performs 4 functions basically. First is data acquisition, second is network data communication, next is data presentation, and last is control. You will see data acquisition. You will see for monitoring so much software, like you will see on field instrument there are so many sensors are there. So many sensors to get the graph thing, like pressure sensors, temperature sensors to acquire the temperature. This sensor is fed up to that system, whatever system is like SCADA. The input will be given to the SCADA. For this purpose, data acquisition is required. So this data acquisition is sensor signal. Data acquisition contains amplifier, filters. Like the sensor signal is so much minimum to get its signal to the higher extent to assess the SCADA. It will use data acquisition. After sensing this, whatever if SCADA gives the temperature at 250 degrees and our requirement is only 200, means it is more than basic requirement. So what SCADA will do? It is will control the action through operator, and then it goes to the actuator. Actuator should be any valve or any motor. Means if my tank is there, the reaction is done in that tank. Any process, any fluid come in that tank, and if my temperature goes beyond 250, means 200 means what? Sensor send that signal that it is 250, more, then shear shows error. And same thing with SCADA, the same way that valve or that motor will stop or it will vanish. The same thing we will see in the next. Network data communication. In last we will see a communication network is required to monitor multiple systems from a central location. As you will see in the back, that is a central location. My laptop. These all things are outward. So these all things are done using communication network. Same thing. Next one is the data communication. Means to report to human operators over a master station. Means whatever they will see on the this operator tells to the SCADA, we will see doing work on the SCADA, whatever being the problem, that is the data communication. Last one is the control. Control is nothing but, as I said, I will sit here in control room and doing any action. My plant will be vary or the temperature should become lower, maximum pressure should be lower, maximum and all. Next one will be, these functions are performed by 4 SCADA components. First one I told sensor actuator. it takes the data. Next one is the remote telemetry units, means RTUs. RTUs serve as local collection points for gathering input from sensors and delivering from our control relay. See, as I told, relays. In previous case, relays are used for the same purpose, means controlling actions. Case sensors give the command to the relay. It means they energize the relay to change their state and do the controlling action. The same thing doing here, the sensor gives the signal to this RTU and RTU use that signal to control relays or control component or SCADA. Next one is SCADA master unit. SCADA master unit means main system SCADA. Then what happens? Master units provide a human interface to the system and automatically regulate the managed system in response to sensor input. In whatever input comes from the sensor, that sensor input gives RTU to a SCADA master unit. SCADA master unit what will do? Means if that is the temperature larger than the basic, the pressure is larger or lower than the basic, then it will performing the control task to control that pressure. Next one is the communications network that connects the SCADA master unit to the RTU. Means same thing, that networks are which are show LAN, Ethernet, WAN. These all the communication network that connect the SCADA master unit to the RTUs in the field. Next, SCADA features. We will see in the lab view. Lab view is purposefully based on the GUI, graphical user interface. Means whatever you want to design, you will design on it. In MATLAB also you will design in GUI. Same thing is your GUI, interactive, fast, precise, authentic and user friendly. Means user friendly, you are whatever is your application, you will develop. You will develop in the SCADA. No need. Then next is trend. Trend is the two types, real time and historical. Real time trend, I will tell you historical trend in the first slide of SCADA. Real time is whatever is doing in the plant going on, it will record it in the SCADA. At every 5 days, 6 days back, if my head will come and he want to see how plant is going on, he want to see check the results of last 5 days, if plant is any problem or what. He basically see that things. Next one is the historical. Historical, same thing with that. Real time is all real things, and historical means it is already stored in the history. Next one is the alarm feature. Alarm feature is what? To set certain parameters for the alarming conditions. Same thing I will tell you here. That is my requirement for temperature is 200 degree. If the temperature I will set one base like 200, so I will make 10 degree and 190 degree. If my temperature go beyond 210 degree, so what I am giving this condition for my alarm users. If the temperature goes like below 90 degree, so what? Same thing I will give condition in my alarm users. The next thing is recipe management. Recipe management for same plant we can do different kind of production. Means recipe management in the same plant within the SCADA. I have designed one plant, like I have designed a cold drink plant, and same plant I will use for some or same layout I will use, but the same layout I will use for different plants, like in oil also liquid fluid, or same only the applications required. Next one is the device connectivity. Means connect itself to various things. SCADA has one advantage that it connects with 2 or 3 PLCs. Means whatever PLCs are in the plant, one PLC, whatever controls like one PLC for boiler, one for painting operation or anything, it will at the same time do with SCADA. Means SCADA also have the functionality like different screens. On one screen I will do boiler operation, on second screen I will do paint operation, and I will manage from the central unit. Next one is database connectivity. Means communicates with any system. This means whatever I told you, save in the field or whatever data it will be recorded, I will easily found in the MS Excel sheet, and I will show you my box or any reference I will put, and in the future I will use that reference. Next is the security. SCADA also have protection. There is also passkey, passwords also, these things also. It protects the data. Whatever will if your plant suddenly fell down, so it didn't reject already saved. When my plants again start, my SCADA again start, I am easily available that previous data. Like script is whatever program we write in this box, it runs on its own. Means script is one of the functionality of SCADA. Whatever I put in that functionality means there is a box. If I want to continuously run the process, then I will put that process address or number in that box and it is easily working. Next one. Why SCADA? Means it is nothing but the advantage of SCADA. We will see here some SCADA screen is there, small. That is for power line. Whatever example I give you about ABB, the same thing will be there. You will see save time cycle. In relay, when they are used, we will see relay having the problems like it is for single relay only 2 or 3 operations should be done. But with SCADA, we will do lots of applications and it is user friendly. Then it saves time and money. Next is less traveling for workers. For example, helicopter ride. I will tell you, my plant is in another city and today I am coming here. Same thing you will see. Lots of time very in doctor is in America and he want to the patient is in India. He will see the video conference and telling all the things. Same here. In that field, doctor only tells and other doctors are working. But in here, he will manage the plant from the other side. So next is reduce manpower needs. As we read in automation industry, the workers the accuracy is increased, but workers will be reduced and the human errors will be minimized. The next one is the feature of the SCADA, that is script. The next one is the why SCADA. You will see one SCADA operation will be shown here, like power line I will show you, like in the ABB they will use these tools. So that power line will be there. Same thing, we will see why SCADA is, which is nothing but the advantages. First one is save time and money. As I told you, SCADA is save time. As to money is referring to the relays, lots of relays they are using, that is somewhat costly. But using a single SCADA, they will control 3 or 4 PLC at a time, so the cost will be reduced. Next one is the less traveling for workers. The same thing I will tell. I am sitting here, my plant is there. The same thing will be happening here. Next one is the reduced manpower needs. As I told you, automation removes the manpower. Means regret the manpower. Means they didn't have don't have direct involvement of the man or person. Next one is the increased production efficiency of a company. Is the accuracy, the production will be increased due to this automation. Next one is the cost effective for power system. As I give you the one example. Next one is the save energy, reliable and supervisory control over a particular system. Means supervisory control over a particular system is what? I am controlling a single system or a power system from another place for a control system. I didn't want to go there and for any error, any problem. If there is any major error, I will go. But for minor error or I want to change the parameters and all these things, I am sitting in the control room and doing all the things. So the time of that worker will be reduced or less, and the efficiency of the system will be increased. Next thing we will see, that is SCADA developers. There are so many companies who develop SCADA, PLCs. Basically, we will see Siemens and lots of PLCs and SCADA in their field. Nowadays also nearly 80%, 90% PLC and SCADA is an industry used by Siemens. So first of all, one is Walterware Indus. It is one of the basic SCADA inventor. They are giving lots of scope how to design and all. Next is Rockwell's RS232. Then I will tell you Siemens. They are sell their product. Next is GE, General Electronics and Integration. Next is Sentec. They have plant line. Next one is Seven Technologies. They have IGSS. Next one Yokogawa, which is a Japanese company having fast and tools. Next is Hathaway. TAS 4000, TAS 4002 products are there. Next one Immersion. These are also very doing so much strength in the process automation. I mean Delta and Provox. And last one is the Europe Supervision. They were having Panorama 8, Panorama.net. Means these are some million companies, but there are lots of companies who are working on SCADA and develop SCADA. Next one. Next we will see PLC. PLC, as I told you, it is the advanced for Even we will see one difference like microcontroller and PLC. Some having confusion like microcontroller. If we burn the program on microcontroller, we unable to change that program. We will change it. Afterward, we will again refresh it and doing in the flash and software and running all these things. But in PLC, it is live. It is having hardware software. This is the hardware PLCs. On software, the same PLC and software. On software, you will change the parameter. You will see that is visible in the programming manner. Like I will show you one. See, this type visualization should be occurred on the PLC on the screen, and we will change the any plant parameter on the PLC. Next one is how PLC differs from PC, not PC. The computer is optimized for calculation and discrete tasks. The computer is programmed by specialists. The PLC is designed for logic control and regulation tasks. Means PCs are doing having for several roles, but PLC is only for logical control and process control applications. This one, the PLC is programmed by non-specialists. Computers are programmed by specialists, but anyone can design any program in the PLC and run it. Next one is a PLC is well adapted for industrial environment. In industrial environment, it is only good. PLCs we have seen in corporate world or in the educational system. So many applications are there for PC, but it is only specially designed for according to industrial environment or for educational purpose to teach the student. See, this is the one of the diagram for that. This is the PLC. Here you will see digital input output so much. In PLC there are two things. One is same as SCADA. Sensor use PLC. PLC used to actuate. Means what? Whatever I sensor sense on the field instruments, it will give the input to PLC. PLC actuates the thing. In a sensor, like whatever, and in this input part, you will see push button also. Then your sensors like temperature sensor or pressure sensor. In actuation part, you will see valve, motor, or any actuates thing like light, LED, same thing. Here what happens? This is the switch. It gives input, gives output. One thing is remember that PLC is work on 24 volt PODs. Second thing, it is used output to the line, which is convertible. This is high, this is for signal cable, this is normal cable, this is 110. The same thing as relay. When my relay is energized, it is connected to the light and my light will turn off. Then next one is PLC architecture. Now we will see in PLC actually there are so many things. One is the processor which performs these logical operations and mathematical operations. Then next one is the power supply. The input power supply I told you at 24 volt. Even in the relay there is a 9 volt relay, so there are 12 volt relay. So DC relay to there. That will be the processor. Next one is the programming device. Whatever I am this user interface, this thing, whatever I am doing this is going to the processor. Text. Okay. This is used for human interface. This is input module. Input module is what? This sensor. Whatever I put here, field instrument will be connected here. There are so many cables like some analog connection input also, digital inputs also. Same thing as output, digital input outputs also, analog outputs also. It is different for different kinds of companies. PLC manufacturer, it varies for the inputs also. From sensor, what I am saying. That is going to output module. The output module will be alarm, solenoids, valve, motor, LED, etc. So that is the architecture of PLC. Next thing is hardware overview. See, whenever we want to buy, there is one product company there. If If you want to buy any PLC, this number is important. I am reading this catalog number for Siemens and Allen Bradley PLC. So see, this is the number 1761L20AWA58. When I am ordering PLC to industry, I will use this kind of number. So what is this? One is the 1761 is the bulletin number for Allen Bradley PLC. Then you will see L is the base unit. 20 means what? Sorry. 20 means what? Unit IO power. Means how much input outputs I want, I will place here like 20. Next one. A is for input signal what I want, 120 volt AC or 20 volt DC. This is my configuration. Means PLC works on 24 volt DC and in the AC format it is 120 volt DC. Next one is W. W means what? Output type. Output type what I have to connect? WEA. Means if it is W. Same thing. Here I put A. A means what? I want 120 volt AC. If I place B, is I want 24 volt DC. As say, if I want for use for relay, I will put W. I want use for cross point, I will use B. For dry, I will place A. Same thing. For output source A. A is 120 volt, 240 volt AC, 24 volt DC. Whatever I want, I will put A or B. Analog input output I will place here, and minus I will want analog circuits. Means 4 inputs, 1 output is equal to 5. So this is the catalog number for ordering the PLC. Next we will see the hardware feature of the controller. See, here is the what I am saying. This is the PLC. Here is inputs, outputs. Here also some LED indicators are there. Power when PLC is on, the LED will grow. Second run, when PLC runs, it runs. Then fault, if any problem in the connection or any plant sensor or what, it shows fault. And forcefully I want to do some program. I know that it is correct, but sometimes the software error shows that it is problematic. So I will use this things. Now I will see the first block. This is having input terminal. Second, DC output terminal. Third one, which is here shown, it is mounting port. Then fourth one, I show these are the input LEDs. 5 one, these are the status LEDs. 6 one is the RS232 communication channel. One more thing I will tell. RS232 is easily not only used in the PLC, but in so many applications we use RS232. But other interfacing devices like I told you in SCADA, Ethernet and all these also interface with PLC. Next one is the 7. These are the all output LED. Then 8 number. These are the power line. What is 24 volt DC or 120 volt AC. Then 9 one, it is a ground screw. And these 10 one, these are the output terminals of the PLC. 3 is the mounting ports. These all things we will see in the PLC. Next one is the working of PLC. These are the some advances in the PLC. One is the source mode, second is the sink mode. Source mode is what? Positive supply is given to the PLC. And sink means negative supply is given to the PLC. Therefore, you see the sink and source mode mainly define the way in which the IO is connected to the IO of the PLC. For this, you will see sinking input, sinking output, sourcing input, sourcing output. These are the basic circuit diagrams. And digital input is what? Sensor, push button, selector. Means it is also differentiate in inputs like analog input and digital. Here analog input, you will see normally means values will vary. This is the PLC original. And sensor, push button, selector switch, it is vary only 0 and 1. Same PLC. You will see same as in input, output also are there as analog input and digital output. In analog input, we will see mass flow controller, pressure regulator, position sensor, whatever I want to do. And in the output, I will see LED, small motor, relay, the same. Next is programming language. In PLC, I will told you earlier there is hardware and software. But in software, you want to do some programming there. What is my programming is there? Like I will place one data diagram like small. This kind of programming I want to do in the PLC. I will explain you later in the next slide the programming of this. So this type of programming you want to do two different things. So first is the ladder language. like this. Second is the functional block diagram, means MBD. In mechanics you will see the MBD blocks. It is most commonly used ladder language. Secondly, in industrial environment, we use functional block. It is easily see the all functions and blocks in there. Then next is the instruction list. Instruction list is nothing but microcontroller list. There we use assembly language. The same language we will use in the IL. Next is drive functional block, DFD. This is one of the programming languages. And last is the structural test language. These are the PLC programming languages. This is the basic thing I want to show. In ladder logic, I will explain here in my seminar. One is the normally open. This is the normal. Before that, I will tell you some basic about the ladder logic. You will see. In this side, one thing is there, here is something programming, and this goes. This is the first step. In second step, I will do something like this. In my both the things you will see. Even addressing is also different in the PLC. Here I will explain basic language symbols with in Allen how it name, and in Siemens PLC how it name. Now I am going to the basic. These symbols, whatever is present. Some first basic symbol is normally open. The name implies it. Normally open is what? My switching action is like this. My switch is normally on. Now I am giving input at 0. Output at 0. If I give input at 1, I get output at 1. Means my supply is not going. In ladder logic you will see the supply is going from left to right. When I am placed here normally open, means my supply is not going. When I put this switch off, means when I get any signal to switch this connection off, when it placed here, then only my signal allowed to pass. This is what normally open. In normally closed, different thing will be happening. Different thing is what? It is normally closed switch, already closed. So when my supply is going from left to right, supply is always in the any kind of PLC going from left to right. You will see I am getting 0, 1, 1, 0. Means it is already closed. When the signals come to this address, or I will press the push button of this, my signal will opens. Means first it is closed, normally closed. Name implies normally closed. My supply is going what? But if I press that button, my supply will close, and I get if it is 1, I get 0. Both the switches are opposite to each other. Next one is the coil output. Coil output, this is the output thing like this. Here whatever I will place, it is motor or wall, any addressing I will do here. So these three are the basic programming languages, basic symbols of the ladder diagram. Here I want to say one more thing. Like here we see the basic add operation. Here normally open. Means here 0, here 0, here 1, 0. Means normally 0, 0, 0, 1, 1, 0, 1. Output is what? 0, 0, 0, 1. Means what? Now both are 0. Now both switches are open. See.
Okay.
You will see 0, 0, 0, 0, 1, 1, 0, 1, 1. Is what? we will get this is 0, 0, 1 into 1. Means we will see there are what happened? Two normally open switch. Means now our position is what? This is 0, 0, okay, 0. If my manual switch will off, my supply is not there. If I getting switch off, my supply is not there, I will get output 0. And when I get output, when my both switches are closed, this also 1, this also 1, then only I get 1. The same operation you will see for OR gate, NOT gate, NAND gate, NOR gate. Same thing you will do there. One more thing. In Allen Bradley, the programming of ladder logic should be done like this. This is my program. This is for Allen Bradley. For Siemens, what happened? This is my network, not run. Network 1. Here what happened? This one, same thing, but it's cuts separate for separate. This is continuous operation in heavy Siemens. Even in Siemens, the writing, the addressing is what? I0 by 1. This is my port, second input. For output, I will put O01. In Siemens, you will see addressing is different. It is what happened? I0, 0. Same as input. But in output, we will get Q. Same thing you will see in Versa PLC also, they will get Q as their output. Somewhat minor differences are there, but the functionalities are big differences in that. Like in Allen Bradley, less functionalities are there. In Siemens, we will see lots of functionality with accuracy is large in Siemens. Even you will see in C language, we will use loop. If I want to repeatedly doing one action, I will form a loop like for loop, while loop. In Siemens, they will use one provision like LP, means functional block. There are three types of functional block in Siemens PLC. There you will create that block as a loop, consider that block as a loop, and we will provide the information in that block which is repeatedly after some time. In Allen Bradley PLC, this functionality is not available. Next is the addressing format, whatever I will say, that is output 0 input 5. In output O, it is for Allen Bradley. For Siemens, it is Q. Other are same here. The status as battery, timer T, counter C, R. In PLC, you will see there are timer counters are used. The same thing in microcontroller. P on timer on delay, P on timer on delay, RDO repeated timer, CPU counter, CTD counter. These both are counter, RES reset, and these two upper three are timers. Even you will see in the Allen Bradley, these three counters are there, but you will go in the Siemens, there are 5 or 6 types of timers are there. Timer T1 timer is what? Now I will start the timer. After 10 seconds, the light will go. When I press after 10 key, I press the T. After 10 seconds, my light will go. It is T on time. But I want to go at my home. 2 hours my plant will close off, shuts off. So what I am doing, I set 2 hours in the timer and I will go in T of timer. After 2 hours, automatically my plant or my lights will shut off. Same as the counter. Counter means every signal when comes, when interrupt will come, then only it counts the pulse. In countdown, it backward means reversal action of the counter will be done, and reset is done for reset all the things. So what timer I will show you. Timer will be T4 has to 0. It is a series. T4 has to 0, T4 has to 1, T4 has to 2. without timer. In which ratio my time runs like 0.01 seconds. Means my timer count with 0.01, 0.01, 0.3 in this interval. Same we will select an accumulator. Accumulator is what I want to set the time. For what time I want to start the time. Like I will set in 15 minutes. So interval 10 seconds runs till 10 minutes, and after that T on is my life. Same thing, reversal will happen with T on. In counter you also have the same thing for counter and counter. Next one is T on timer. Yeah, I will show you this. Timer, time base. I will show you in accumulator. In accumulator you will see the value while running. This is counter. In counter I will tell you this is preset. You want to send a value. In counter you want to place for in 5 for counter balance battery for that. In accumulator you will see the output. This is see you when is my reaches my limit. The high otherwise it will go down. There is a mathematical in relay you will see lots of wiring for every single relay. Here is a less wiring. Second is the wiring between devices and relay contacts are done in the PLC program. Easier and faster to make changes. Troubleshooting and setting program easier and time. Next one is a reliable component. Things likely to operate for years before failure. The reliability and the failure time. Reliability is last one and failure time is next. Next is application of PLC. As I told you, handling application, usually industry, printing, food and beverage. I told you, Coca-Cola plant and water machine. Manufacturing American side. One thing, Allen Bradley is a product name. It is designed by Rockwell Automation. Allen Bradley is the inventor, basic inventor, known as the basic inventor of the PLC. But nowadays, in everywhere, Siemens PLCs are used due to their reliability, compact size, and accuracy. So, second one is ground loading on Texas Instruments, General Electric, Westinghouse, Cutter, Square D. In European, you will see Siemens, Klockner and Moeller, Festo, Telemachine. Even we will see Festo is available in hydraulic and pneumatic circuit design. Next is Japanese, Toshiba, Omron, Canon, Mitsubishi. In Japanese, Mitsubishi is popular. You will see. Omron also is there. You will see now the next thing is the basic thing which I told you earlier, like PLC SCADA communication. We want to nowadays develop an application using PLC and SCADA both. In SCADA, we will see the graphical programming. So whatever problem in the plant, you will see directly on the plant. Even in PLC, you will see. But in the air, in this one, you will see this is the one round. And this is my motor. If my motor will fail, so it only shows the red indication. Even in the SCADA, you will see the layout of the motor, and that will be so it is better than PLC system and differentiate the thing. Same way, you will see in SCADA I will monitor from here and my process from the field. The same thing here. So how it communicates the SCADA system with the measured flow and levels and send the same set point to the PLC. See, two PLCs are there. This is flow, this is pump, this is level, this is valve control. All the things for measure PLC one compares the measured flow to the set point, control the pump speed as required to match flow to set point. Maybe it shows that this is the result of PLC. Same result goes to SCADA. We have PLC to compare level and valve control with the set point, and all the things are going to SCADA. If there is any problem or error occurred, SCADA PLC gives an indication from SCADA, even PLC got that indication and control the field stream. That's why the working of SCADA and PLC. SCADA doesn't directly communicate with the field hardware, as I told you earlier. It communicates with the PLC. Second, it checks true and false statement in PLC. PLC gives either 0 or either 1, as I show you in their basic symbols. Next one, the SCADA has substitute mode and HMI. In the second or third PPT, in the introductory part, I tell you, in automation tool, one tool is the HMI, human machine interface. You will see same figure will be showing on my mobile type panel. You will see the how the flow and all these things are going on, and you will just press the keys. It's same working as SCADA HMI. Next one is HMI. It is used as a small part as it is cheaper than SCADA. This is one of the example or advantage of HMI. HMI is different in SCADA is different in, but you will even use SCADA as a HMI. Like same thing, you will see all sensors are transducer, but not all transducers are sensors. Same thing, all HMIs are SCADA, but not all SCADA. All SCADA HMI. Same different thing we will show you. Next one. This we will see how this works. First one is the sensor placed in the field. It gets the input, that going to junction box, send the conversion amplification will be done, data collection will be done, and that things are going to the control panel. Control panel is nothing but PLC. And this PLC then communicates with SCADA software. The same thing will happen. SCADA will give the indication to control that any error is there. PLC is controlled by going through the junction box using actuators, not sensors. Next, combined applications of PLC and SCADA. We will see where PLC and SCADA combined use, like gas industry. I actually told you. Second one now in water filling plant, the various operations it will be used. So first we will go with automation of tank level. Means what? This is my lower tank. This is my upper floor tank. This is my pump to pump the water. Now using PLC and SCADA, what I will do? PLC is nothing but controlling the pump only. Even in PLC and SCADA, you will see whatever water level will be increases. It means these are the different outputs you will see. 50, 51, 52, 53, 54, 55, 56, 57. These are the levels. When it is at 5, it sends the command output to 5 to PLC, then it's open, and then PLC will generate any signal related to that addressing. These are the addressing, output addressing. Same thing you will see here. This is a high limit switch. One first limit switch, this is second limit switch. Both are inputs. Means what? When my water level reaches here, my PLC works and open this wall and water will flow out. This is not actually industrial application, but it is nothing but to learn how PLC and SCADA combined will work. Next we will see, this is the PLC wiring diagram. Same I will tell you, like this start, stop, resetting, drain valve and all. Same I will show you one program in electronic style. Let's see the same program we will learn. This is your first input. This is your second input. Means this is limit switch 1. This is limit switch 2. Where we will see? Here. Now this is my Q 5.1. Now when my level reaches to that, the 0.51 it starts, and I am giving this limit switch input same to. Now what I am doing? This is normally closed. It already working, and this is open one. Means what? When it is high, it gives signal to this. Due to what? I am saying this is normally closed. If it is give signal, it opens. Due to what? My valve opens and my flow main valve will open and close outside. Same program you will do in a broader way using latch and all these things. Stop. Here you will see the SCADA of this. Whatever you will do there, this is lower tank, this is upper tank. This is the non-positive displacement pump. Whatever water will come, it injects and going to it is measured. This is the limit speed. This is water. Whatever is going there, see here are the outputs on which level the water will be there. It shows here. And according to that, send signal to PLC and it reaches to the last limit at 1000. It is current level. My valve will opens and flow goes out. Next, water cleaning plant. In water cleaning plant, both systems work simultaneously, SCADA and PLC. Here you will see level sensor is there, IR sensor is there, input module is there, signal conditioning circuit is there, PLC, SCADA. Means what? In water cleaning plant. See, this is my conveyor belt. Now my bottle is coming. Here I have proximity sensor, here I have level sensor. When my bottle comes here, my proximity sensor detects that water. That my bottle is there. Now, when it is here, my PLC opens the valve and liquid falls down. When that liquid level reaches to this limit switch, limit switch sends signal to PLC and tell that stop the flow. Means it close the flow and my water will be killed. Same thing. Input model signal conditioning PLC. Same. When it will pull the limit switch, it will send output relay output. Again my actuator is my motor will start. My motor will forward and another motor will. You will do a simple program for that. I will show you that program. So what to do? This is my R1. I put it as the R1. This is my first input, that is start switch. This stop switch. One thing in PLC I will forget to tell you that you will see in the PLC there are lots of analog input output and I am showing there. Here also some switches, according to arithmetic, here also some switches which are normally closed. For that, here some LED indications will be given. Means this switch is normally open, it is not blue. If this switch is on, it shows it is closed. It is not blue. If some switches are normally closed, normally open. So according to universal accepted start stop switch, this is the design for that. This is my motor of conveyor. This is I am matching conveyor motor. Means if my supply fails or input fails, my supply is going through this path. So whatever I am doing here, I told you that normally I am giving here normally open and for stop I am giving normally closed. This is the universal accepted methodology for stop knowledge. But here as our signal point of view, I am using normally to stop the system. Now, when I press the start button, my conveyor on, my motor is coming. Now, when I press my proximity sensor, detect the water. I am pressing one normally level, giving same addressing of proximity sensor. When my proximity sensor going to high, it detects the water, it will touch. This will open, so my conveyor will stop. At the same time, proximity sensor is closed. So I am giving this output to
wall. Means that water forms in the water, means that cold drink falls in that bottle and my volume. Now, next one is the limit switch. When it reaches to my limit switch, what I want to do? I am doing some output here, but what normally goes is here. Means at this position, it will stop the wall. And same thing I will do here conveyor motor on. This is what happens when I put this limit switch, my conveyor motor is again on and next one will come. Same thing we see here. Press control interface, this is the bottle, automatic, close. This is SCADA level. See there is a Siemens SCADA simulator. You will see the SCADA, how the wall will come, how we. Same, this is one of the short programming I will show you. But the same programming, even this image will, you will place one normally over here. Two, not here, sorry. So I am matching this. What happens when it is high? It will on and my supply will go. PLC programming is not a big thing, but how much you reduce that programming, that's all your knowledge. We will see the next part. Boiler temperature control. Now what happens? This is the SCADA level. Water pump, heater, anode, warming. Here we see our pressure in the boiler. It will display here our temperature, how much volume, this start time, this stop order. Same thing, minimum limit, maximum limit. Now my wall and the temperature is going there. Boiler to volume on. Now temperature control as I told. If my temperature, if I set to boiler 1000 degrees centigrade, means I am giving the limits of this 1200 degrees centigrade to 800 degrees centigrade. If I want my temperature vary, it is set to this. So what happens when it goes beyond? Means where fluid is so much hot, it open the wall and my fluid will come out and my temperature comes down. But if my temperature is going down, then what? It increase the temperature of the boiler to enter. So PLC and SCADA both are doing the same. Next one is here you will see the PLC as I told you, the extension plants for the PLC. You will see this SCADA. Heater is there, you have water pump to throw out the fluid. But heater to increase the heat of the boiler to come to the diaphragm. So finally, today what you will see, what is SCADA, what is PLC, what is first of all, what is automation? How automation can be done by using PLC SCADA? First I will tell you some basics. What actually the SCADA will do on the field instrument. Then about PLC, we will explain briefly. We will learn briefly about PLC, how it will work, how it will communicate with field instrument, sensor, actuator. Then we will combine to see the operation of PLC SCADA for water treatment plant, water operation, water level control. These 2-3 applications we will see. Then in the last, we will see the various companies are doing manufacture PLC SCADA. So even nowadays DCS, distributed control system and LabVIEW are there. But till now PLC is the most reliable and SCADA is the latest one used for that. Even SCADA is used for different purposes also, like that power line controlling or any voltage control application or any remote sensing control application is there. SCADA. So basically this thing is very important for process automation. manufacturing line